Yeah, so I think a graph is one of the most indispensable tools in describing a function, right? When we want to get visual intuition, it always works. When we want to get understandings of calculus for that matter, it always works. That's kind of where it's coming from, right?
Mm-hmm.
So what I was telling you guys before we even went on the air is the fact that we're talking about functions. Probably I said is the second most fundamental object of math. The first being a set, and the reason I said that is because at least in set theory, functions are sets. And what set is that? It's the graph. Anything you want to know about a function can be told from the graph, and vice versa. They're isomorphic in that sense.
Mm-hmm.
I don't mean that super rigorously at all, but I mean any information the graph of a function can give you the same way the rule and the codomain and the domain can give you, which is just what the function is, right? It's a domain, codomain, and rule. That little group of info is all wrapped up in just knowing what the set that the graph forms, right?
Mm-hmm.
So
And can
that's
you?
why, yeah,
Oh, sorry. I was just gonna say, like, can you explain why a graph is a set?
surely, yeah, because it's just going to be the list of ordered pairs. Right, so if you took all the ordered pairs and you sandwich them between some curly brackets, as we do,
Mm-hmm.
you'll get a set, right?
Because the
And
set is just a because just set is just a fancy curly bracket
you just throw
at the
some
end of the
things
day.
between curly brackets.
Mm-hmm.
Sets almost anything you want it to be. That's why
Yeah.
it's the most general math object.
And like I said earlier, a relation is just a set of ordered pairs. You might have noticed, like Matt literally just said the same thing for a function. It's just a set of ordered pairs. But in this case, you need that specific quality that if you have one input, if you have an ordered pair in your set, the first input cannot be repeated twice, right? And that's pretty much all the information you need. Because if you have every single input and their outputs, then you probably can't do it by hand, but if you have a
Mm-hmm.
computer, boom, you get the graph. But one thing that I kind of realized, which was kind of like naive of me to think before I got to university, but like for some reason in my head, every single function was somewhat nice. You know what I mean? Like there's a hole in the function, or there's an asymptote or something like that. But like things were, somewhat piecewise continuous at all times. But when I got to first year, you encounter things like the floor function and things like that. And also the function that we use oftentimes to like, this is often used to provide a counter example to some things. And it's the function where it's 0 if you're rational and it's 1 when you're irrational. And that kind of broke my brain when I first saw it, because I was like, how is this a function? But you think
Mm-hmm.
about it in the most like simple sense, and you're like, yeah, I mean, it satisfies all the conditions you need to be a function. So yeah, I guess it is a function.
Mm-hmm.
The delta function. I mean, there's so many different types of functions that I guess we may be able to touch into today. I mean,
Yeah.
I don't know if we're getting to the specifics, but we're just talking about mainly the beauty of functions itself.